All right, now, so like if we're happy with the idea that we would need such a thing, such a methodology, then let's go ahead and make this methodology in mathematical terms, and then find out how we can do it, right? So our goal, so what we would want to have is like goal number one. We would like to represent. So we want a representation. We're representation learning right now. It's the simplest one, but it's representation learning. So we would like to represent samples of my data sets, x of I, which are in d-dimensional. So d is like a scary number, like 63,000 or 6 million, whatever, you name it. Represent all of these samples that come from, they are from a domain or a training set. I'm gonna call it X, which is like all of these x1, x2, yada yada, x of n, right? So I have n of them. So this is my training set with a representation. I would like to represent with a representation z of I, right? Each and every one of them, I don't want to call them like now x. I would like to call them z. I chose this letter because in the deep learning literature, this is the letter that they call for latent variables. And this z is hopefully not as big as x, so it's in r to the k, and I know k is less than or way less than d, right? So that's how I would like to represent. Let me write it. Significant less than d, right? And 2. Okay, so the next thing I would like to have, obviously I would like to learn, so this is important, learn this representation from data, because there exists some representations, such representations that has nothing to do with the data. You can, for example, you can have discrete cosine transform or Fourier transform of any data, and you can still compress your dimensionality, right? So, but this time I don't want to use a predefined transformation, right? 3. So these are the 2 things, and okay, this transformation I want. Whoops. Let's write with black. I want a linear transformation. To get this representation. Okay, and 4, I would like to have the best. I would like to have the best representation. And 5, okay, this is good. I would like to have each dimension in the new representation introduce something new. I mean, this time I would like to find such new dimensions, like k of them, such that they are not collinear. Maybe they're better than that. Maybe they're orthogonal. If they are orthogonal, then that would really be amazing. So that's my goal, and I would like to find this projection. Well, I would like to find such a W, find such a W that I would like to represent my new representations with some inner products, because I want linear, right? So let's remember from from projection theory. So if you have not watched this video, or if this is not like projection theory is not fitting well with you, I will recommend you to go back and watch that like 10-minute video. In a projection theory, if you remember, we were mentioning, so we were in 2 dimensions, we were a data point here, and if we were to represent this data point on some direction, I'm going to call this direction W, the best representation of this this data point on this W was the one that was obtained with an orthogonal error, right? So that's the error error signal, and so that's I can call now. I'm going to use the terminology with the nomenclature with the reconstruction. So if this is your x and this is my x hat, and if I were to find the z here, which is a scalar, I learned that the best z was the one that I get with x transpose w divided by w transpose w, right? So this was the best representation of x on w, right? So this was the best representation, right? So the x hat, then I can reconstruct x hat using the w only, is just zw, and which was w times x transpose w, w transpose w, right? So this was it. And if w is a norm vector, meaning w squared is 1, then I would have my z is just inner product, right? So w transpose x is my z, right? So that's my z. Now so this was our remembering sheet, but now I would like to take it to the other side. Now I would like to also find 2 things, like one, what is this w, right? So that's what I want, and 2, what is the best representation, I mean z, on this w, right? So the projection theory answers number 2 actually, right? So but I still don't know what is w, right? So right now I would like to find this w. I would like to find a w that's going to give me the best representation, actually the set of w's. So now the question is, let me write it now. The question is, what is the best w? So, and I'm gonna assume, like, first I'm gonna start with just 1D first, right? Let's go ahead and assume just 1D, and I would like to build on top of it, right? So let's start with 1 dimensions and build on top of it. So I would like to minimize. I would like to minimize the reconstruction error. So I would like to reconstruction. I don't know why it doesn't like my wording. Maybe this. No. Okay. I'd like to minimize the reconstruction error. So I would like, I'm going to have some x minus x hat. So that's the reconstruction for all of the i's. So this is the reconstruction error, and I would like to have the mean of this because I have I equals 1 to n. So this is my data set. So this is my data set. And obviously I would like to have the average of it. It doesn't matter actually. Mean, absolute error, mean squared error, sum squared error. Like it's going to minimize the same thing because this is a constant. I would like to minimize this error. So this is my error, and I would like to have such that I know the reconstruction is going to come from such that my w square is 1. So I know this w is just the direction. So minimize the reconstruction error, and I would like to find. So I would like to find some w star, which minimizes, right? So I have talking about some argmin over all of these w's that minimizes this w, this error. So 1 over n summation I equals 1 to n x of I minus x hat of I squared. And I would like to include this guy, and I include it with lambda, right? So I would like to include it such that w squared minus 1, its distance from the unity is also minimized, so it is enforced to be linear. So that's the first direction, the best direction, like 1. If I were to find one such direction from 63,000, and don't worry, we'll go to the new directions. So that's the minimization error that I would like to minimize, and believe it or not, w exists here in this x hat x hat of I. So I'm going to minimize this.